Let's work on Leetcode 3196, maximize total cost of alternating subarrays. So this is a dynamic programming problem. So let's see what this problem is about. So we are given an integer array names with length n, and the cost of this subarray is defined a little bit different than we usually see. It's from L to R, and it'll alternating plus and minus each number. So this is nums L minus nums L plus 1, then plus nums L plus 2, then etc. So our task is to split these numbers into some subarrays, so the total cost of the subarray is maximized, ensuring each element belongs to exactly one subarray. So we can see the data range for this problem is relatively large. So this is a very strong hint that we are using the dynamic programming to solve this problem. And there's a hint that the number is very large, so we need to use long here. So let's just using LL as long, and then we define a state ij, and I can be any number from 0 until nums size to nums size, and j is just 0 or 1. Okay, and I is num size minus 1, I think. So fi0 means the max total cost from 0 to position I with nums I with a positive before nums I, okay? And fi1 is the maximum cost from 0 to I again, but with a minus sign for nums I. And then we can have the state conversion function. So for this one, it's just equal to so because we have a plus sign here, so we just need to consider I minus 1, right? So it's I minus 1 and I minus 1, 1. So it is the maximum of these two. Of course, plus is itself. Okay, and this is the first state conversion. How about the second one? So from I1, this will be maximized I minus 2, right? Then for I minus 2, it can be 0 and can be 1. It doesn't matter. However, for the I minus 1, it should be positive, so that nums I is negative. Okay, then I think that's it. We have the state definition and state conversion function, and we can write the code now. So we say n equals nums size. Then we define a vector long, and f. So this is n, then vector long, and 2, and initialize to a very large number, actually. And we can define this very large number to maybe 1 in 9, okay? Oh no, I think we cannot define it just 1 in 9. There will be some issue because each number is 1 in 9, right? And we have 1 in 5. So 9 plus 5 is 14. Let's say if it's like this, then how about the boundary condition? F0, 0, it just equal to nums 0, okay? And F0, 1, we don't need to initialize this, right? So for I equals 1, I less than n, okay? And we need to define a return value. So we need the maximum, right? So the return value is, let's see, is 0, okay? Because we will have a positive return value. Yeah. This is guaranteed because we can select where we start. So then, no matter how, if suppose we have a negative result, then we just flip all the choices, then we will have a positive. If you really care about this point, you can just make it this way, then nothing will happen. And we will write the state conversion. So first we have this one, I0 is this one, and for I1 actually we need to consider some boundary conditions. So if I equals 2, what will happen? If I1, it is just equal to f nums 0 minus nums 1, right? Because we only have 2 here. So this I minus 2 is not valid. Let's see here. Okay. So if I equals 1, then we need to, if I equals to 1, we need to have special cases, right? If I equals 1, then I1, what is I1? It is the first number. So yeah, it is the first number and this is the only choice. We don't have I minus 2. Okay, otherwise we have I minus 2. We can use this state conversion function. And I think we just max, we don't need the res actually. N minus 1, 0, and f n minus 1, 1. Okay, and we can delete this line and this line. Let's see. Other compiling issue. Yeah, we have a comma here. Okay, it seems correct, and let's submit. Yeah, it passed. So the key idea here is we need to find this Fij state. The Fij means from I is from 0 to nums size minus 1, and the max total cost to when we reach the index I, and with position I is a plus sign, and Fi1 is the maximum total cost when we reach position I, with a position I number with a minus sign. Okay, then we have this state conversion function. Then we need to consider to pay more attention to this boundary condition. And yeah, that's it. Thanks for watching and see you next time.